In this interview, I talked to Dr. Greg Maguire, who is the founder and lead scientist at Neogenesis. He is what I lovingly call a gentle giant. He has a giant brain and a giant heart, and he just wants to do so much good for society and people. And I hope you enjoy this interview. We go more into the science about why Neogenesis works and how it can help you. Enjoy.
Okay, so I have a whole list of questions for you. We have shoppers that get confused when they read stem cells in the product description of Neogenesis products. Would you expand upon the form of stem cells used in the products and where do they come from? And would you confirm that it is stem cell molecules, not DNA of any kind?
Right. So in the Neogenesis products that have the so-called S2RM technology, and S2RM stands for S, stem cell released molecules, and the 2 designates that the molecules come from more than 2 types of stem cell. So it is the technology, the S2RM technology, is the collection of molecules that the stem cells release. And it is not taking a stem cell and chemically and mechanically crushing it and pulling out molecules. It is allowing the stem cells to release the molecules naturally. And when they're released naturally, all these different molecules are formed correctly. They're in their native state, their natural state. Because if they're in the molecule, they're being processed. They may not be in their native state yet. When they're released, they are. And so we take those molecules that the stem cell has released, and only the molecules. It is the molecules in the S2RM Neogenesis technology. It is not cellular material, and therefore it is not DNA.
Isn't it true that if you were to put actual whole stem cells in a product, it would just die? They just die anyway? I mean, that's generally what people, they'll crush them up and they're already dead or whatever, but you've discovered that if you just wait much longer for the exosomes that they get delivered, a natural way, the way the body's used to.
Yeah, that's the way the body does it, is that the stem cells in the body, or even when stem cells are being used as a therapeutic, say they're being transplanted into the patient, most of the therapeutic benefit of the stem cell, even if you put stem cells in the body, the therapeutic benefit comes from mostly all the molecules that are released. Yeah. And so, yes, if you try to put the stem cells into a bottle and then have that bottle on the shelf of the professional, such as yourself, then she or he, would probably have dead stem cells.
Yeah.
You could make them last for some finite time, but it's not what you want to do anyway, because really the horsepower are the molecules the stem cells release, not the stem cell. Now, interestingly, Christine, it's just a side note, but we know even approved bone marrow stem cell transplants, which we don't use bone marrow stem cells, and I can tell you why, but even approved bone marrow stem cell transplants cause many negative effects. And so when the stem cell comes into the body and implants itself, it doesn't do so in a natural state. And because of that, it actually ages the tissue that you've implanted the foreign stem cell into.
Oh, wow.
So
the opposite effect.
Yeah, well, it does provide benefit for blood disease because the bone marrow stem cells will form the blood, but the bone marrow stem cells have properties that aren't suited to be present in the skin for any length of time.
What about fat stem cells? I hear about this all the time, how they're better and that they help the skin. I've had people argue with me about that, and I'm like, okay, talk to Dr. Greg.
Yeah, so stem cells in the skin, the mesenchymal stem cells, will make fat cells.
Okay.
Bone marrow stem cells in the bone marrow also make fat. So skin stem cells make fat cells. Bone marrow stem cells make fat. There's fat in the bone marrow. But it's a matter of the stem cells making what's needed for the particular tissue. So stem cells resident in the dermis and in the fat pad underneath the dermis are making the cell types and the molecules needed to keep the skin maintained, healthy, for the duration of your life, fight infection, fight inflammation. They're the ones that are there day in and day out through our lives. They evolved to be there and take care of our skin. It's just as we age or we have improper lifestyle or we've got certain disease that the stem cell function can come down so that the molecules they're releasing might not be configured properly. There might be fewer of them. The stem cells may not be able to make all the cell types that they need to make so efficiently. This is a big part of aging. And with aging comes increased risk for diseases. So these cells are very, very important for, yes, making fat. And by the way, fat is critical. The adipocytes are critical to wound healing. So if you look at Elaine Fuchs' work at Rockefeller and some of her colleagues, she's an excellent scientist who works in stem cells and skin and hair follicles. You will see from the work of her and her colleagues that the adipocytes are very important player in wound healing. They're critical to the skin. You need that fat layer working properly. Something that most of us have been guilty of at certain times in life is eating a little too much, maybe drinking a little too much, gaining a little bit too much weight, putting on a little bit of extra fat in our fat pads. The fat cells will become larger when we gain weight. It's a problem in obesity. The fat cells become larger and the blood supply doesn't feed them as well, and the fat cells start making inflammatory cytokines.
Oh, wow.
And they actually build up these crystalline structures which are detrimental to our health. But that's not the mesenchymal stem cells in the skin doing that. That is the fat cells, once they've differentiated from the stem cell, if they're not properly treated adipocytes, then they'll turn into what we call a phenotype, a different cell type essentially, that starts secreting some of the negative cytokines instead of the positive cytokines. So it's really a matter of controlling not only what you feed in internally, because a lot of the stem cells in the skin and elsewhere, they derive certain molecules from the blood. What's in the diet goes into the blood and feeds some of the stem cells. Like linoleic acid from plants comes through the blood and is transported to feed keratinocytes in the skin. And those keratinocytes, of course, are stem cells. So yeah, you have to feed all of the cells, including the stem cells, everything they need through the diet, but also based on a lot of good scientific work, you can feed the skin some of the molecules it needs from the outside in, including some of the lipids. So a number of scientists throughout the world, including in the dermatology department at University of California, San Francisco, have showed that you can feed 3 different lipid types to the skin, and they'll diffuse down through the skin, be taken up by the keratinocytes. The keratinocytes will pump the lipids in, and they'll form these fatty lamellar bodies and pump them out and form the stratum corneum, your protective barrier.
Wow.
So we have a product that we release that has...
Oh, yeah. Is that how that works?
Yeah, it has the 3 lipid types and other molecules that help form naturally the stratum corneum and your barrier function.
Yeah, I'd never heard it put that way. That's cool.
Yeah, it's
The way it
really...
works, actually, and not just covering it. It's being sucked down and made new. Sorry, going back to the question. So there's no DNA in this product.
Right. There's no DNA.
So the second question is, in your opinion, what makes the S2RM technology superior to what is found in other skincare lines? So that's sort of feeding into why fat stem cells and all this don't work as well as skin stem cells, correct?
So what we're doing really is taking a process of evolutionary medicine. What did the skin evolve to do in humans in order to maintain and to heal itself? What are the basic processes that are going on in our skin? And understanding that, and yes, we've done some of that work, but it's much the work of scientists around the world, understanding the skin. And learning from these scientists, we see that the skin depends upon really several different types of skin resident stem cells to maintain and heal itself. And we see that the way that the skin works is using combinations of stem cells collectively, synergistically, to maintain and heal the skin.
Yeah.
And so what does Neogenesis try to do? We try to harness the molecules that each of these different types of stem cells releases into the skin in order to provide those molecules to your skin that as we age or we go out and party Saturday night too long and stem cell function comes down, as we age, stem cell function comes down, we can return those molecules back to the skin. And so using the combinations and the right combinations, not a foreign stem cell that has untoward effects on the skin like a bone marrow stem cell, we choose the stem cell types very carefully and the molecules that are released, not extracting the molecules like some companies do, and return all of those properly foreign molecules to the skin. Now, some of the other companies will crush a stem cell, extract the molecules. And that means a lot of the molecules are proteins.
Right.
And proteins exist in a three-dimensional state. They have to have a particular shape in order to work correctly.
Right.
And if you pull them out of the cell instead of letting the molecule release, the proteins oftentimes aren't formed correctly. They don't have the proper three-dimensional shape. So you have to be very careful about using the proper proteins from the correct stem cells, making sure that they're formed properly, and then if they're in the exosome, they're protected and they won't lose their three-dimensional property. So we've done the science to look at the exosomes and look at the proteins inside the exosomes of our technology.
Is it true that one of those exosomes can hold up to 20,000 proteins?
Yeah.
That's insane.
Yeah, so I published that it was a book chapter I did in 2016. So I took other scientists' work and they did some calculations. And based on certain dimensions of the exosome, based on how many proteins can be packed together and the protein size varies.
Mm-hmm.
But it can be the case on average that an exosome will have 20,000 proteins in it, yes.
So this little bottle of Neogenesis, this little bottle of recovery, you think, I'm telling people 4 to 6 drops, and they don't even know the goodness they're putting on their skin. So now they might start to understand. It's such a vast subject, but it
is vast, and you're asking the important questions, and once people hear some of these questions asked and hear some of the answers, and we don't know everything, but we have some very good understanding of the stem cells, the molecules, the exosomes. Once you hear what's known, then you have a greater appreciation of what you're doing with this little couple of drops of recovery. Someone once asked me, they said, Greg, as a scientist, you can't see what I see because you're always busy looking at these small molecules. I said, oh, no. I see what you see. I'm a human being. I see the big picture. But because I have tools to see the small, I can see the small within the big picture, unlike you can.
Oh, yeah.
So you see things perhaps differently if you're an artist than I do as a scientist, but artists and scientists are much the same. We have a particular way of looking at things. Scientists and artists alike will look holistically if they're good scientists, but also reductionistically. And a lot of artists know very well about
with macrocosm.
Yeah. So once you see more and more holistically, as well as the bits and pieces that make up the whole, people can have a much better appreciation of these products, the technology, and what it's doing to the skin. So that's part of the education.
Yeah, I think people, they don't even know what they don't know with this product. I'm really glad that they're starting to understand maybe a little bit. When you use it on your skin for a couple of years, you realize just how healthy and good your skin looks compared to somebody else your same age. And you're like, there's just a clarity and a perfection to it that I don't see in other skins, but a toughness, tenacity.
And that is the beauty of it, is we have a technology enabling the skin to be healthier, and therefore it's going to be better looking skin. But the key for me as a scientist is to create things that are for health.
Yes.
Not cover-ups, and I allow the other people, importantly, to do their work on cover-ups, because we all appreciate those things. But my direction in life is to create science and technology and better therapeutics and to make the skin. And I work in the brain as well. And so we're publishing and
Well,
actively.
you let me know if I can have some of that.
Well,
If you have some Neogenesis for the brain, I'll take it.
we do, because we're working, amongst other things, in dementia and amyotrophic lateral sclerosis. So you can take these molecules, and one thing to put them into the brain is you can put them into the nose.
Just thinking about that, yeah.
The nose has, as you know, has a very rich vascular bed, and the exosomes will go up and enter that rich vascular bed, and then quickly go up into the brain. And then if we want to put it into the spinal cord, we can actually, they'll perfuse in, but we can also do intrathecal injections as well as the nasal spray. So people can come in and have an intrathecal injection with their physician, maybe weekly, but also on a daily basis, maybe 4 times a day, put the molecules into the nose. So we're trying to work those things out as well.
Wow, that's so fascinating. All right, so this is a part of Neogenesis that I don't really understand very well because I'm not a stylist. I don't work with hair a lot. But next question is, would you tell us how the hair, lash, and brow product line works? Does it make hair thicker, grow faster, etc.?
What we're doing with hair growth, so that hair follicle, whether it's here in the scalp or the brows and lashes, there are conserved features in all of the hair follicles, including stem cells inside the follicle, but also stem cells surrounding the follicle and the skin, all of which work to make the hair and make the pigment. So you're also making pigment that injects into the hair shaft. And all of that is very richly controlled by various stem cell types. And this is where Elaine Fuchs really does a lot of very good work at Rockefeller. The hair follicle is an important model for all of stem cell function because it's a constant cycling process. You go through the phases of growth and rest, basically. Long story short is what we're doing with the Neogenesis hair technology is returning into the hair follicle and to the surrounding skin those stem cell release molecules that are normally there to keep the normal hair cycle going. So if you better enable the hair cycle, then yes, you're going to enable thickness, pigment, hair growth. So again, it's not a foreign process. It's a matter of renormalizing hair follicle function. I use the product a little bit when I remember to from time to time. When I use it, my hair goes a little less gray, but to be honest, the product works better in women than it does in men.
I wonder why that is.
Well, we're very difficult beasts, as most men know. And we have too much testosterone floating around in our bodies, turning into DHT, and the DHT degrades the hair follicle. So we're trying also to overcome that. That may be one of the things that men have that hinders our product from working as well in men as it does in women. But even men, a lot of men see some increased hair growth, and even some of my friends who are older and have beards, they put it in their beard. It will turn the beard darker.
So women especially can expect just a thicker. I've seen it regrow dark hair, like you were saying.
Yeah.
But thicker hair for sure, and sometimes more.
Yeah, sometimes more. We've seen, particularly, with working with some professional women who, 30s, 40s, into their 50s, who, are traveling a lot, working hard, maybe raising children along with that. They're super stressed. They're on game, almost 24/7, and they're super stressed, and they start just shedding the hair. We can really help those women. We've seen that quite dramatically. So.
Oh, wow. Yeah, that makes sense to me. If you've been under a lot of stress, then that will help most. Well,
yeah,
that's cool. I love this. It's filling in all the blanks for me. The next question is, tell us why it matters that this product is Oncology approved, and tell us about the work Neogenesis is doing with the oncology community.
Yeah, we're very, very happy and proud to be working with the physicians, estheticians, the patients going through various forms of cancer. The product is approved for oncology because this is a technology that actually, we can't make any claims, But looking at work, our work, but more importantly, work at some of the major medical centers, if you look at the proteins that are in our S2RM technology, they actually will inhibit a number of forms of cancer.
Oh,
So
wow.
even melanoma, just one of the proteins in our S2RM mix, it's a protein called HAPLN1. And HAPLN1 binds together laminin and collagen. So it's kind of an instruction molecule saying, hey, laminin and collagen come together and bind. And when you lose HAPLN1 as you age, you have less and less of it as you age, then the matrix is deforming. And one of the things very important in cancer is laminin function. So if your laminin is not binding your collagen, you have loss of function in the matrix. Matrix has a lot to do with controlling cancer. Now, this was taught to me at Berkeley years ago by Mina Bissell. So Professor Dr. Mina Bissell is one of the key players in saying that cancer really much less probability of happening if these cancerous cells exist in a normal matrix. The normal matrix tells the cancer essentially stop. But if you have a mutated cell with a deformed matrix, you have an increased probability of cancer.
This is almost like a snag and pantyhose, sort of.
Yes, yeah. The matrix is gone and it's just going to kind of tear apart and keep propagating. And so, yeah, so if you rebuild the matrix, putting back in proteins and other molecules to normalize the matrix and other functions, then you're decreasing the probability of cancer. We also, with this set of molecules, we quell inflammation, important in most cancers. Cancer is associated with an inflammatory state. And so we actually do things with these molecules where we bring down inflammation in both the innate and the adaptive immune systems. So that means macrophages in the innate. It means T cells in the adaptive immune system, very important for cancer. And we quell the inflammation. We bring the skin back to a normal state. So because of this, we're able to work with cancer patients using these products to not only treat, for example, radiation dermatitis. So when a patient is irradiated,
Yes.
we've all, I think most of us have seen that skin.
A family member of mine just went through that, and he was so grateful for the recovery I gave him. He's like, I don't know, out of all the products people were throwing at me, that worked the best.
Oh,
And
so good to hear.
Yeah.
This is my charge in life, so it's really good to hear.
Really great.
So we can treat the radiation dermatitis where you have the inflammation, you have the broken matrix, you have damaged DNA, damaged protein. So one of the things going on in our skin too is that the skin, a lot of proteins in our bodies are very long-lived proteins. They don't turn over very often. And so if they're damaged, they can be oxidized and damaged. You'll have them in your body, some of these long-lived proteins for years, maybe a good portion of your life. So you have to repair them. And our molecules repair those proteins, whether it's aged skin or irradiated skin, we're in there repairing because we have something in the molecules called the antioxidant cascade. We don't just have one antioxidant, we have multiple protein antioxidants in these molecules, and it's the antioxidant cascade that will help to repair DNA, help to repair proteins, and help to prevent DNA and protein damage. If you just, for example, flood in a lot of vitamin C, you don't see this antioxidant effect. You can have negative consequences. You can actually cause oxidation. But when you use the multiple antioxidants that the S2RM has, then you're setting up the antioxidant cascade and preventing and actually helping to repair damage. So we can now go in, putting the technology, the S2RM technology, onto the patient as they are treated with irradiation, and we can, to a large degree in most patients, prevent radiation dermatitis.
So you put it on before?
Yeah.
Oh, okay.
So there was
that makes
concern.
sense. People
There was
wait and do it
concern.
after, and you're like, no, put it before, you know.
The physicians and the physicists who know about the radiation. So every radiation center will have a physicist who is there to control the machinery and make sure the dosing is correct. And the physicists were concerned that if you had a product on the skin, that it might essentially act as a lens and concentrate the radiation and irradiate just a portion of the skin with too much.
Right.
And then other portions not have it. But it's been shown that that doesn't happen. And so now we're allowed to put the product on going in for treatment, and we can help to prevent radiation dermatitis. So that's pretty exciting.
Yeah, that's awesome. I didn't know that. I'm going to have to, well, people will know now if they listen to this. So.
Yeah, we're very excited about that, because that will, as most of us know now, skin is the largest organ in the body in particular, if you induce inflammation in the skin, even in the stratum corneum. So even if you do tape stripping of the skin and you induce inflammation by damaging the stratum corneum, the scientist in multiple places, but the scientist at UC San Francisco looked in humans, and they saw that even damage to the stratum corneum, the distal layers of the epithelium, that will induce systemic inflammation.
Really?
Yeah.
Well, I mean, it makes sense, because if you get sunburn, think about how bad you feel.
Yeah, it's really true. So then they showed that if they repaired the stratum corneum, repaired the distal part of the skin, then they showed systemic inflammation was reduced.
Nice.
So we know that many diseases, particularly diseases of the aged, involve chronic systemic inflammation. So what you do as professionals in better treating the skin and controlling inflammation here can have very good consequences to systemic inflation and chronic diseases.
Wow.
Really,
I never even thought about that, but yeah.
It's really very recent work. That work had been done in animal models, but the UCSF scientists did it in humans and did a very good job and really showed this to be true. So we need to be very careful as we try to fight infections or deal with infections, that one of the things you can do, even in terms, and I'm not saying this is a preventative or a cure-all, but one of the many things you can do to better prevent a viral infection is to bring down inflammation chronically. So if you have chronic inflammation, likely you're going to have inflammation in your upper respiratory tract, which will set you up for easier catch of something like the SARS-CoV-2 virus. So even what you do in the skin to reduce inflammation can have consequences to preventing and even helping to mitigate the effects of a viral or bacterial infection. So doing all those things possible to put your whole body in a better state, is critical to mission.
I think it's important to note too how much work you do with oncology patients, that your goal is to give away or offer at a reduced price, like help 1 million cancer survivors through
that is a team mission, and
yeah.
Steve McGee, our CEO, has been very good at,
we've worked together.
Yeah, you guys work together great.
Yeah.
I'm so happy to see the two of you engaged, at least on a weekly, if not daily basis, in helping your patients and your clients come through various problems. And so Steve has really made it a mission of our Neogenesis team. And we're a small company. We have a family. It's a family of people, and all of us really embrace that mission to do good for mankind. And one of the targeted areas that Steve really developed for the company was to work with estheticians, physicians, to bring these products to people in need. A lot of people, given our healthcare system, if they have cancer and they're being treated, their monies have been depleted, and they just can't afford these non-prescribed products, or even if they're prescribed, you see people can't afford those, even if they're under an insurance plan. So we want to really help those people. And so Steve has an idea of, it's like 1 million people we're wanting to serve. And if we can grow the business, we'll make that even bigger. Some of the technology I would like to bring to the third world. We have eye drops that help with not only the cornea, but with the lens. And a lot of the people in the back parts of India and back parts of China, for example, and in Africa, they'll have, as they age, opacities in the lens, cataracts, and they become blinded and dysfunctional.
Wow. Yeah.
And they can't see an ophthalmologist because, one, they don't have the money, and two, there are no ophthalmologists for them to see.
Right.
So they can't have a simple cataract replacement surgery, but we have eye drops that can help remediate and prevent that. So
Are those are prescription?
well, they have been on the market as an OTC because they fell under OTC rules.
I feel like I need them.
We're trying to work with regulators to find the right path and then help
Right.
bring these to the people who
Yeah.
need them. It's just not always easy doing those things, but that too is one of the goals, is to help the people, our brothers and sisters in need around the planet who are not as fortunate as we are here in the US. So we have these goals. We have to make some money to keep the mission
Sure.
alive. This is, as a scientist, university professor, you don't go into that field for the money. You go in to learn new things and try and help the knowledge base and help translate the knowledge base out to the market with the company. So that's what we're involved in doing.
That's awesome. So is there anything new on the horizon you can tell us about? Are you going to bottle these cataract drops and give them to let us estheticians?
So we've used the cataract eye drops with a number of ophthalmologists, some nurses, and we've seen a good effect. So we're trying to find the right investors and partners to work with on that project. Some of my partners on that side of things, it includes Steve McGee, but there's some other people that work with us. My old friend Peter and some others that, we're trying to find the right group to work with us on those. But, the newest thing we have at Neogenesis is that product I told you that feeds lipids to the keratinocytes and helps to build naturally the stratum corneum. So we're excited about that, because if you
we've gotten really good feedback on that so far.
Good.
Because we got a little bit of a supply that came out at first. And we've gotten some really good feedback so far. People are loving it.
Now we prioritized you because you use it correctly, and then you tell us, you give us the feedback about what's working, what's not working. Hey, it works with this person, not with this type of condition. So we love working with you because you are a co-scientist with us, a collaborator, but also an educator. So it's very important. Well, it is, because until you put these products out into the real world, even with clinical trials, oftentimes you take a drug through clinical trials, and once it goes to the market, there's a high percentage of drugs that go to the market after 4 to 7 years, they have to be recalled, because the real world data tells you things that constrained clinical trials don't. So having these products in your hands is all important.
Well, that's great. I love to be to help. We love to help with that.
We need you as a collaborator. We're working on products. The one other key to a lot of disease states throughout the body is the microbiome. And so that includes the skin and the microbiome.
We need a microbiome hand cream right now.
Yeah, well, one of the things that has been shown for some of the disease states, atopic dermatitis, is that the whole collection of bacteria, and there's many different types of bacteria present on the skin, that the whole collective of bacteria has somehow shifted. And actually, a scientist at UC San Francisco she's shown that in particular, one of the bacteria is not present in atopic dermatitis. That same bacterium is also absent in those of us that suffer from chronic sinusitis.
I know, I need a swab of their.
That's what we're working on.
Transplant.
Yeah, that's what we're working on. So we're working on putting a return of normal to the microbiome here. And then I'm also experimenting with a nasal spray that includes the certain, it's called Lactobacillus sakei or Lactobacillus sakei, depending on how people pronounce it, but that bacterium is gone.
Huh, I didn't know that.
So we're returning a collection of bacterium, including the Lactobacillus acai, back to the skin as well as in the nose, and it seems to help because I suffer from chronic rhinosinusitis.
Mm.
I'm one of those atopic guys, and
Atopic
it
guy.
help when I put it up into the nose and the upper respiratory tract. So I'm testing that.
Well, that's awesome. All right. So my last question is, do you have any new books? We talked about this briefly earlier. Any new books? And if so, where we can find your books online?
Yes, the book about stem cells was published, I think, about a year and a half ago. It's online. It's on Amazon, but it's very expensive. It's a science book written for scientists. So it goes heavy duty into physics and chemistry and physical chemistry. So if you're a super nerd and like
So if
reading,
you're into that,
if you like reading about quantum collective coherent dynamics as it relates to stem cells, that's the book for you.
okay.
It's very nerdy, very scientific, but that's available, and it's I must say, a unique perspective because it talks about the collective and how everything works together. The more recent book is called Thinking and Eating for Two, the science of using systems 1 and systems 2 thinking.
What's that about?
Well, as we go through life, our brain works in 2 basic ways.
Oh, it's right brain, left brain, sort of.
Systems 1 thinking, systems 2.
Okay. I gotcha.
And a lot of what we do, the way we evolved, is to proceed through life based on what our brain learned early on.
Right.
And you just become reactive to things. It's quick, it's easy, it's fast. And if you evolved in a certain environment, having quick, easy, reactive thoughts that control you, you don't control it. It's in the subconscious mostly. A lot of what we do, we don't recognize. It's done subconsciously until someone points it out. So that systems 1 thinking is quick, it's reactionary. It's evolved to get us through most things in life. But life has become very complicated, and there's a lot of challenges and a lot of things we need to understand and to deal with that really need deep thought. That's systems 2 thinking. And that involves scientific, evidence-based, rational, and it involves looking at the whole,
But isn't that right brain thinking that comes to you in the shower? It's like when you're trying to figure something out and then all of a sudden, boom, it just hits you in the shower. You're like, there it is.
When people
but we're taught
about,
to not really listen to that. But that's a shame.
So
here in the United States, I know in other cultures, they really embrace it a lot.
Yeah, so as a neuroscientist, I'm a professor of neuroscience. Both sides of the brain are used all the time. And this right and left brain is...
We think that they're working together, though. They kind of fight each other all the time, don't they?
They work together, and they have to. And if you can cut the corpus callosum and have 2 brains, but...
Wasn't that Albert Einstein that had... Yeah.
Most of us have...
Didn't he have no corpus callosum? Albert Einstein?
He had a very rich corpus callosum and
Who
all
is
of his
it?
brain pieces working together.
Nice. I would love that.
There was a scientist, she just died 2 years ago, Professor Dr. Marian Diamond at Berkeley, who actually had part of Einstein's brain. So Marian Diamond was the scientist that discovered neuroplasticity. So the environment actually changes brain structure, brain chemistry, brain function. Marian Diamond discovered that at Berkeley as a professor back in the 60s. Unfortunately, she didn't win a Nobel Prize because back then, even more so than today, women didn't tend to get Nobel Prizes.
Mm-hmm.
Very sexist system. But anyway, she was one of the people that was studying Einstein's brain. She actually had at least a piece of Einstein's brain she was studying. It was a brain that wasn't abnormally large, but it was a brain that was rich in connections. It's a very interconnected. This is part of the work that, as a brain scientist, I work with computer scientists developing new computer structures, and they were actually interested in our work because the horsepower of the brain is not that the neurons and the individual elements are fast. They're very slow. They're much slower than a computer element. But the key is the brain is very highly connected.
Yeah.
Lots of synapses, and these synapses move, they change. They some of them actually physically move, but they change their structure and their amount of signaling between the synapses.
How they wired together. Yeah.
It's how they're wired and how that wiring changes. That is a big piece of the computational horsepower of our brain. We're going a little far afield, but I enjoy talking about this.
I love this stuff.
Yeah. So they were the scientists at Berkeley and Caltech and other places were developing computers. This was someone that we worked with, a guy named Carver Mead, professor at Caltech, actually developed a whole field called neuromorphic engineering, actually making computer chips designed on how the brain does it.
This is like AI, right?
It's part of putting AI into a circuitry that works well. Yeah. So it can actually be a part of making AI work well. Yes.
So that's what your new book is about.
So the new book is about how is it you use your brain to think about health. So if you're walking around the planet like most of us, simply using systems one thinking, this reactionary thinking, you watch a commercial on TV and you believe it. So they show you something on TV that's a bunch of fried fatty food.
Oh yeah.
There's nothing green on the plate, and they say, hey, this is comfort food, you're going to love it. And you start salivating. That's systems one thinking. The systems two thinking says, oh, I read Dr. Maguire's book, and he said that if you eat too much fat, that you actually induce a lot of disease through various mechanisms, and that fried food has a lot of advanced glycation end products that cause inflammation and may help to misfold the proteins in my brain. That commercial is wrong, and I'm not going to eat that stuff. So I go into all the mechanisms of how you have to think about things, how a lot of experiments may be not only interpreted wrong, but the experiment was set up incorrectly.
But so much advertising speaks to that part of our brain. It does. It's a trigger. Yeah, it's all a trigger.
And they rely on your systems one thinking, knowing that they can push you into systems one thinking and you won't ever engage systems two thinking. My book is telling you to engage systems two thinking. Think about what you eat and your exposome, all those things you're exposed to in life. Understand it, and once you become habitual in the practice of what you're thinking about, that information is eventually pushed into systems one thinking. It's like when you remember when you first learned to drive a car?
Right.
You had to think about everything you did. Oh, I'm going to make a left turn, so I have to turn the wheel this much. Oh, I'm turning too much. I need to turn a little back this way. You thought about everything. The gas pedal, I have to push just...
Everything is conscious. It's all conscious, and then it gets pushed to the subconscious later on. It's automatic.
And it's automatic. Yeah. So you have to learn to think about the food, learn to think about, the nutritional study, they said this food is better than that food, but the food here they compared it to was traditional American diet, full of fat, fried foods, too much meat. And they said, this is better. Well, of course it's better than that, but you have to ask compared to what? What was it compared to? Was it compared to garbage? Well, this is better than garbage, but doesn't mean it's good.
Right.
Compare it to a good diet, compare this to a good diet, then this is no good. So I always tell people, think of this question as one question you must always ask. Compared to what? One of my favorite jazz tunes is called Compared to What? And I always play that for people, and I say, think.
Compared to what? I like it.
Yeah.
Well, thank you, Dr. Greg. I appreciate your time today, and I hope to see you soon. I don't know when I'll see you. Maybe another Jane's get-together.
Let's get together. Let's get through this COVID-19. Let's come together, hopefully sooner than later. Let's continue this education. I thank you so much for the opportunity to be with you and all of the people that you educate. This is really important that we educate more and more people and, entice people to think better about what they're doing to their skin and other people's skin. So I thank you very much, Christine, for the opportunity to be with you and help in your mission of educating others.
Thanks.